All right, so it's all about circle trigs. The next test is about properties. Properties number 2. And there's no calculators on this test, and you're going to be doing a whole lot of circle trig. All right, first of all, do you get that the side that you start at here is called the initial side, and then they're going to sometimes refer to the terminal side. That's the pink one here. So sometimes the terminal side is at like a point, like right here. And by telling you that, they've told you that the one side is 2 and the other side is 4. That's like 2, that's like 4. Okay. Otherwise, sometimes they'll just say that the terminal side is at like pi over 2. Hopefully you know where that is by now. How about that spot? What's that? Pi. And what's this next major spot? 3 pi over 2. Good. How about one that would be normally called 30 degrees? What would that be called? Pi over 6. How about the one that's exactly 45 degree angle? Pi over 4. Somewhere about here is, no wait, about here is about a 60 degree angle. That would be what? Pi over 3. Okay, good. So what if it's 2 pi over 3s? That's like 2 of these. So 2 pi over 3, here's 1 pi over 3. And that's about a 60 degree angle. Here's 2 pi over 3s. It's about a 120 degree angle. All right, so just a quick reminder on that. Next thing is, they're going to ask you about quadrants. You got to know which quadrant is which. And we don't want to call them the ASTC quadrants, even though they have those labels, A, S, T, C, to tell you that all of them are positive. Your sine's positive, your tangent is positive, your cosine is positive there. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Do you remember that those are the quadrant names? If you don't, then you should write them down. 1, 2, 3, and 4. They go in a C shape. C? Okay, anyway. Let's talk about a real typical problem. You're going to have, like cosine of, let me see here, 5 pi over 2. Of course, it's not a nice question, but it's something like that. Would you give that one a shot? And if it turns out that that's not in a place where you could draw a triangle, then you better have some other skills for handling those kind where you can't make a triangle. Take your pencil. Don't just try to, quote, do it in your head. Not good enough. You could be writing. In case you're stuck, the first thought would be 1 pi over 2 would be right here. And then you count it up from there. There were 2 pi over 2, 3 pi over 4. Do you realize that 5 pi over 2 ends up in the same exact place? Good. But you can't just say, okay, I'm done. So did they give you sides or did they give you an angle? They gave you an angle. So what did they want? They want something like sides. They want a ratio here. They want some kind of like something over something. But how do you do that if you don't have a triangle? You remember the x over r thing. Very good. Because cosine of anything is x over r. Sine of anything, if they had asked you that, that would have been y over r. And tangent of anything is y over x. So really, we're in this one, so they really want to know x over r. Again, I don't have any numbers, though. What did I tell you to use if you didn't have any numbers? Zeros and ones. Okay, so radius would be 1, so we're going to make this spot right here 1, comma what? 1, comma 0. And this spot right here, 0, comma 1. And I'm not going to keep going because that's the one I need right there. I need this because that's where I am. Okay, so then, what's the x? 0. What's the r? So it's 0 over 1, which is equal to what? 0. The answer to that one is 0. You can just say 0. Do you need to memorize these? Absolutely. You need those. All right, let's try another one like that. Let's say it was tangent of 6 pi over 4. Tricky there. See if we can handle it. Hopefully you didn't get too far thrown off by this. 3 goes in here. or no, 2 goes in here 3 times 2 goes in here twice. It's really 3 pi over 2. And that's really this spot right here. Another spot where I can't draw a triangle. So I go to, what is that point right there? 0, comma 1. And what is tangent of anything defined as? What over what? Opposite of adjacent, yes, but what over what? Y over x. So if we're talking y over x, the y is -1 over the x is 0. What happens when you divide something by 0? The answer is undefined. Who said it was undefined? Good. You're right. Thank you. She was here. Back row. All right, so let's move on to, do you get this kind? Are you feeling good about this kind? I need a yes, we can move on, or a no, stay here. Yes, we can move on. All right, good. And if you need to watch those over again, you can always watch the video and see them again. All right, here's the next kind. Let's say we had cosine of theta equals 1/7. Now, so far I haven't told you what I want, but generally you'd be thinking that I wanted the angle, but hopefully you know that that's not one of the common triangles. You don't have a 1, 2, square root of 3 thing going here. You don't know any triangles that have a 7 on their sides. Okay, so it's probably not going to be to figure out the angle. The next part of the question is, if tangent of the angle is less than 0, what was that a clue about? Which quadrant it's in? Yes, that's a clue about which quadrant this thing is supposed to be in. Then the final actual question would be, what's sine of theta? Notice I didn't ask you theta, because theta would be some weird angle, like 22 degrees or 18 or something. Something you wouldn't know without a calculator. So, of course, draw a triangle. If you either draw triangles, or you realize, oh, I can't draw a triangle, and then you use that other thing we just did a second ago. But you can draw a triangle. Pause for a second. Yeah. Okay, back from the pause there. So my first thought on this is, what quadrant am I in? I'm at cosine's positive. All students take cosine's positive in both of these two, so it's not here or here, so it must be here or here. Now, clean up a little bit. So if I'm going to have cosine be positive, I may as well be here, except that it says tangent is negative. So I can't do that. So I cross that one off too. It has to be down here. How many of you are in the right spot? Just raise your hand if you did. Excellent. Okay, next thing is, if I put my sides on opposite, tangent's opposite over adjacent, right? Oh wait, it's closer. Cosine is adjacent over hypotenuse. So adjacent side's 1, hypotenuse is 7. Now my triangle looks really skewed. Okay, you're right. It's not there, it's there. My triangle looks really skewed because it looks like these should be about the same length as each other. So I'm going to redraw my triangle. You wouldn't have to, but it's just bothering me. So I'm going to do it again. I'm going to go like this and say, now it's more like 1 and 7. You don't have to do that, but it sometimes helps you to figure out what kind of angle you got, whether it's like closer to 60 or whatever. Then this side right here, I can figure out, and you will be expected to figure out. So that's going to be square root of 7 squared is 49, minus the 1 makes 48. Square root of 48. Raise your hand if you do that. Good. Then the last question is sine of it. Sine is opposite of hypotenuse, and it's so close to root 48 over hypotenuse of 7, but that is wrong. What did I forget? And said maybe you remembered. Yes. No, that's not the thing. Negative. Why is this negative right here? Because it's going down. Negative. Oh, that's going to be marked wrong so many times. Don't let that happen to you. Okay, because if I had been, for instance, over here, and I'd drawn my triangle here, and this was 1, and this was 7, do you get that those would, one of those would be negative? Okay, and then this side right over here would have to be like square root of 48, and that would have to be negative. Okay, because if I'm going this way, this direction's negative, and that direction's negative. All right, so let's say I was over here. A, B, C. Which one's negative? A, B, or C? A would have to be negative. Careful of the negatives. That's going to get marked wrong a ton. All right, next kind of problem to practice. This one's going to stretch you a little bit, so I'm going to do it early on while you still have a fresh brain. You know these sine things are waves, right? And basically they go like this. And sine starts at 0, and then, so I'm going to make it touch like that. Okay, but what if I were to shift the whole thing up to like, okay, yeah, that would be like sine plus 1. It would just mean the whole thing got moved up. But now, this spot right here, let's say that I said it was pi over 2, comma, 0. And this spot right here, let's say I said it was 3 pi over 2, comma, 2, are a minimum and a maximum. How could I use those to figure out the amplitude? First of all, amplitude means this. It's how big that is, except divided by 2. So, yep, I just take the total height there is 2, and then you could say minus 0 if you want. And then bottom line is, it's 2, but then the amplitude would be what? 1. All right. How about this distance? This one. From here to here. Here to here. That is pi over 2. No, it's more than 1 pi over 2. It's 2 pi over 2. This distance from here to here is pi. So is that a complete cycle for this? No. Half of the cycle. If this distance is pi, then that's half the cycle. The whole thing would be 2 pi. I'm walking you through this because I'm about to change those numbers radically, and you have to be able to handle it. So this period is 2 pi, and its amplitude is 1. Its period is 2 pi. So what happens when I change this to be pi, and I change this to be 3 pi, and I change that to be 7, root 7. Try it again. What's the amplitude now? And what's the period now? See, I know some of you were like, yeah, that was really easy, but take the time now to figure out what you think the amplitude and period. You got the answer or a question? Yes, you can use a ratio, but your answer should be a number. You can leave it as a fraction if you want. All right, so some help. Would you agree that this distance right here is important? How far is it? So what's the amplitude? 7? 3.5. It's half of that distance from there up. Okay, so 3.5. And how about the period? Well, from here to here is not the period. That's half the period. And if it takes 2 pi to get halfway done with this thing, you get how this is 2 pi because it went from 1 to 3. That's 2 pi, then the total period must be what? 4 pi. You get that? Because from here to here was 2 pi. That's 2 pi long right there. Then the whole thing, to finish off, would have to go to here. Would have to double that. It'd have to be 4 pi. Let's try one more like that. Let's say you had, let's go way down this time. Your wave is going like this. And let's say this point right here was at 3 pi, comma, negative 8. And that point right there was at 6 pi, comma, 2. Figure out for me what the period and the amplitude are. I should say the amplitude first, I guess. Amplitude and the period. Almost lunchtime, but it's not quite. Finish this one. Stay with me for this last problem. Okay, in the front row, how far is it from here to there? So therefore the amplitude is? Yeah. Who's got the period figured out? Got it? Tell me what to do. It's from here to here's how far? 3 pi, therefore 6 pi. Raise your hand if you had both of those right. Okay, good. I think you understand that now. All right. Can't quite let you leave for lunch yet. We're getting close, but not quite. I'll just propose the next one. I hope you remember this guy. It's the big formula for sinusoidals. I'm not going to use the letters. I'm going to actually use numbers. What's that thing tell you? Amplitude. This is A. What's this? B. What's this? And this one? Okay. Which of them do you mess with when you're doing period? B. Because period is defined as what? 2 pi over B. And the last thing is the phase shift comes up a lot. Phase shift is defined as what? C over B. All right, we'll talk about more of that after lunch. Go. All right, so to begin again after lunch here, I'm going to give you a problem that's one of these big sinusoidal kind of deals, and you're going to figure out period and the phase shift. Here we go. Let's say it was -6. Let's say it was cosine. Let's say it was 3 pi. Let's say it's, no, 3x, sorry. And then I'm going to subtract pi over 2, and then I'm going to add 7. I would like to know what its period and phase shift would be. The amplitude would be just too easy. That'd be period, phase shift. All right, period would be 2 pi over B, but B is 3. So it's 2 pi over 3. Raise your hand if you get that one right. Okay, good. Phase shift would be pi over 2. That's the C over B, which is 2. That's a fraction. Oh, 3. Fraction in a fraction. So then you really want to do 3 over 1. And now you can do a pi over 2, and instead of divide, you go times, flip it, 1 over 3, pi over 6. Raise your hand if you had those right. All right, good. So I think you're good at those now. Let's move on to something like cosine of pi over 3 plus 2 pi. You get that pi over 3 is like somewhere around there. Okay, so then if I add 2 pi to it, do you get that I'm right back in the same exact spot where I was before? So if you had 2 pi or 4 pi or 6 pi or 8 pi, the exact answer would be exactly the same, so you could ignore that. You get that? All right. What if they don't add 2 pi? What if they add an odd number of pi's, like 111 pi? Then it's moving it over 180 degrees. So this spot used to be here. Now it's going to be here. You go around another 180 degrees, so to speak. All right. So then this, if it was 60, then this part right here would be 60. So it'd be 180 plus 60 would be 240. If that was supposed to be in radians, then you could say that you're really doing cosine of 240 or cosine of, let me think in radians. This is 1/3 of a pi, 2/3, 3/3, 4/3 pi. 4 pi over 3. Now, is that the answer? No, that's just the question. Okay, so I just figured out now I'm supposed to be finding cosine of 4 pi over 3. That means now that I'm making my triangle down here, if that's the 60, this would have to be the 30. This would have to be the 1, 2, 3. Things are negative there and there. And now cosine is adjacent over hypotenuse. Adjacent is that one. Hypotenuse is that one. -1/2 is the actual answer to the question. See how that can be tricky? All right, I need you to try another one like that. Let's say it was sine of pi over 4. Then if I added 2 pi, you would just ignore that. So I won't. I'll add 1 pi. So first figure out what the question really is. It's not sine of pi over 4 anymore. It's been moved. And once you know that they want sine of something else, they've given you the angle, you have to give them sides. Okay, so if I'm doing sine, pi over 4 is this one. If I go plus pi, then that means it's really this one. And that's like, this is 45, right? Otherwise known as pi over 4. Right? So then this would be really 4 pi over 4 plus 1 more, 5 pi over 4. So really this is sine of 5 pi over 4. That's not the answer, that's what the question is. Now what's the answer to it? The answer to it is a side ratio, something over something. So I got to figure out what those are based on my triangle. Here's my triangle. There, there, there. These sides are 45, 45, 90, and so this is 1, 1, square root of 2, but careful. Negative 1, negative 2, or negative 1, and another negative 1. And then, final answer, sine is opposite of hypotenuse, that over that. Negative 1 over root 2. Raise your hand if you had that one right. Awesome. Okay, let's move on. We have all kinds of problems. Try this one. Sine of theta equals negative a half. And I would want all the answers that are between 0, less than theta, less than or equal to, I should say, theta, less than or equal to 2 pi. Let's say that was the directions. That implies I might have more than one answer. I mentioned triangles before. Comes up a lot. So probably drawing a triangle here. Sine is negative a half will not be here because sine isn't negative there. Oh, sine's negative. Sine's not negative there either. So it's one of these two places, or both. And which one is it? One or both? Both. There's two answers. Because I didn't have any extra little limitation like, oh, by the way, tangent has to be positive or something. I don't have any other limitations, so it's got to be both answers. So, I'm going to say sine's opposite of hypotenuse. Opposite sides 1, hypotenuse is 2, but I have a negative somewhere, and it should be there. Hypotenuse can never be negative. And now, can you tell? If I just put a 1 here, it's not going to be one of the ones you've ever used before. So it can't be 1. How about square 3? Is that possible? Yep. All right, and good point. Is it negative? It is. All right, so now, I really just needed to know how many degrees that is, though, and what is that? 30, 60, or 90? The one across from the 1 is the 30. So that's a 30 degrees, and I know kids are going to write that for an answer and think, oh my God. No, not really 30. It's not even pi over 6 because it's this one. It goes all the way around here. So if this is a pi over 6, or is it a pi over 3? Pi over 6? That's pi over 6. If that's a pi over 6, then there was 6 pi over 6 to get to here, plus 1 more, 7 pi over 6. All right, raise your hand if you had that one. All right, a few of you. Some of you probably weren't there. And that's one of them, yeah. Now there's another one over here. And this is also a pi over 6. And so then this would normally be 6 pi over 6, and this would be 12 pi over 6, but we don't go that far. We back it off and say 1 less than 12 pi over 6 would be 11 pi over 6. That makes sense to me anyway. Another way to think of it. I used green. I haven't used green yet. All the way around to here is pi over 6 is like 30 degrees. It's like 330 degrees. So 330, you could change that in using that method of pi over split by pi over 180. You just have to then reduce some nasty numbers, and there's no calculator, so you'd have to do that by yourself. 30 goes in here, how many times? 11. 30 goes in here 6 times, 11 pi over 6. Okay. And one last kind I'd like to show you. What if you can't draw a triangle? Remember that whole 1 and makes things that have 1 and 0? Oh, question first. Yep. Yep, in this triangle right here. Question about this triangle. Well, the hypotenuse can't be negative. We know that for sure. You're right about that. And do we need to, let's put in the numbers here, okay? So sine is opposite of hypotenuse, right? Opposite hypotenuse. What's the opposite side from here? -1. That's how you're going to get your negative. And the hypotenuse is 2, and then this side right here would have to be square root of 3. So it can still work. All right, let's try this last kind. Remember, if you can't draw a triangle, it's because you're at one of these spots. Those are called the quadrants. And then you're going to just say what spot you're at, like 0, 1. And you always use zeros and ones, or negative ones, or whatever. And your radius will always be 1 then, because this distance is the radius, so... All right, so here's one like that. See if you can handle this one. What if tangent of theta is undefined? And your answer has to be between 0 or equal to 0 and 2 pi, or it could be 2 pi. Usually they don't have an or equal to here because 0 is 2 pi, so it's like one or the other. Okay, there we go. Give that one a shot. Can't draw a triangle for that, that's for sure. Can't draw a triangle where you're going to have sides that are 0, and therefore you can't have it undefined, and so you best know those other formulas. This takes a little while to do, but I think it's worth it when you're on this kind of a problem. Over 1, up 0. Over 0, up 1. Over -1, up 0. Over 0, down 1. There, got my 4 major points. It's got to be 1 or 2 of those. Okay. Next thing. If tangents, y over x. Remember tangent of theta. This is where you have to pull this one out of your brain. And we're really saying that undefined is where y over x has to come out undefined. That is telling you something important. What's it telling you? Yes, x is 0. It's got to be over 0, yes. Okay, so x has to be 0. Which of these have x as 0? That one does, and that one does. And these don't. So I'm throwing them out. Let me make sure it's both of them now. Okay, if I actually put in these numbers for y and x, y of it is 1, x of it is 0. Would that one work? Yep, that one works. So this one, which is pi over 2, is definitely one of my answers. Would this one also work? If this is y and this is x, it's going to be -1 over 0. Would that also be undefined? Yes, it would. -1 over 0 is also undefined. So this also works, and therefore 3 pi over 2 is also an answer. 2 answers. Yes, sir. Yep. Okay, usually, the vast majority of the time, this means that there are 2 answers. But sometimes it means there's only 1 answer. And the only situation would be if I had said this. Do you see how I can't be 0 and I can't be 2 pi according to this little formula right here? Because I didn't say or equal to. Then what if the answer is coming out to 0? See what I mean? Then I couldn't write it down as an answer. And then what's the other answer? If it's 0, it's also going to be 2 pi, and that also can't be written as an answer. And so my answer comes out to 0, and I was limited by this, then I couldn't possibly have an answer. So that's a weird case that you're probably not going to see. So that would be a true case where you would have no answer. All right. So I know. Hopefully just Tschüss. Wiederhören. Domo arigato. Okay. Anyway. So, I think we covered it. Covered it. A lot of stuff. I did throw in one new thing. Let's go back to the one new thing one more time. Say you had one of these, and I had a low spot here was like 6 pi, comma, and below it's -3. And a high spot here was like 12 pi, comma, 8. Then, what's its period, and what's its amplitude? Do you get that it's 8 and 3 makes 11 total? So you don't take 11, you take half of that, which is 5.5. Good. Period part. Normally, from something's period is 2 pi, but that's totally off when you have something like this. We have to figure out what the period is. And that's how far is it to get here? 6 pi. And so it's only halfway done, so therefore 12. Raise your hand if you understand that. All right, almost everybody. Okay. So, now you have time and a worksheet. And the worksheet is probably way more important than normal because we're in the hardest unit. I think I'm covering it a lot, making you do lots of practice problems. If you're doing them with me, I think you're learning it. But don't underestimate. You know, this is supposed to be one of the hardest units in precalc. So study for it. Test is coming on Monday. Do all these problems, check them. And I will probably be collecting homework on the day of the test again because it was one of the few days where I actually have time to grade stuff. So make sure your homework's done. Yes, I have a few assignments that are not in the gradebook yet. It will be soon. I have a weekend coming. Yes, sir. The test is on Monday. And then we have like Tuesday, Wednesday is review. And then I think it's Thursday for the graphing part. I think. Because Friday, most of you guys are going to buy your way out of class for that charity thing. And that means we got to get it done before Friday. So. And that's all I got for the video.